What is the background?
Perkins. You don't like the background?
No, I just cannot recognize it.
It's a restaurant.
Where did you steal so much screenshots?
Different places. Okay, so for today we were supposed to look at, I am sharing, right? And I am recording. Pretty sure I did all that. Yep. We were supposed to look at RESTful APIs and how it relates to HTTP. So what did we find out related to that? What is a RESTful API? Let's start with that. What's an API?
The term or how it's done?
Both.
It's an interface, interfacing with applications to retrieve data or
Okay.
send data.
So when you have third-party applications that have data and or services that they want to provide to other things, they can provide an API that allows you to conveniently plug into. So let's just deal with this part. So an API, a mechanism to conveniently plug into a third-party software product to use their data/services. All right, so that's the idea of an API at the high level, right? So what did the earliest APIs look like? So before we get to RESTful APIs.
Before that, I know SOAP, which is the simple object. SOAP used XML. I know that.
Okay, they didn't have to. It didn't have to use XML, but it typically did during that period of time.
I don't know if it didn't have to use XML.
Yeah.
I'm just used to it using XML.
Sure.
I know it's also a Microsoft product, I think.
I'm not sure if that's the case, but whatever.
But anyways, before REST, I knew SOAP, and because I used SOAP with applications that depended on SOAP.
All right, so we might say SOAP and REST APIs are standards by which an API can be written to make itself compatible with these standards such that third-party applications can conveniently interface with them. So the idea is that, we'll say SOAP is a little bit older, a REST API is newer than SOAP, but both of these guys tried to establish a standard mechanism. So if the two of you each ran separate companies and you wanted to provide APIs into your data or your services, you might pick a SOAP or a RESTful API to follow a standard list of things so that me as a software developer, if I'm writing a product that I need to interface with both of your APIs, I don't have to have this custom thing to talk to yours and then a separate custom thing to talk to his. I can talk to both of yours through a standard protocol, SOAP or RESTful, right? And then the only thing I need to change is, maybe your company is providing services A and B, and his company is providing services C as well as data X, Y, and Z, something like that. So it could be that you're different service providers, and what I need from you is different than what I need from him, but the protocol that I'm speaking to them can be the same, right? So in this classroom, we've chosen the English protocol. So we can think of the English protocol as kind of like an API. If I ask you a question, you give me an answer, right? I don't need to switch to a different protocol to talk to a different student. That kind of makes sense? So that's kind of the purpose of SOAP and REST APIs, is to provide that standard.
Okay.
So what did we do before that?
I just need to say something regarding what you just said. Maybe say that REST and SOAP are our guidelines, and the protocol which we will discuss later is HTTP. This is the actual language. Well, not sorry, well, not language, but this is how we're going to transfer data.
Yes. HTTP, though, is not related to SOAP.
True, yes.
So both of these guys have a data mechanism of, let's say, TCP over IP. That's the telephone we pick up to talk to them, right? That establishes a communication channel between the two. So now we are going to speak some language over that telephone call. So in one case, if it's a SOAP API, we're going to have to speak the SOAP protocol. And even back then with SOAP, there was a couple of different implementations of SOAP. So it wasn't even necessarily perfect. You might have had to tweak your stuff just a little bit. If each of you were running a different SOAP standard, it's possible I couldn't use the same central code base to talk to both of you, but I should be able to get pretty close and maybe have to make a few modifications, maybe to talk to your SOAP API as opposed to his, but it should be close, right? So in any case, when we have these standards, the generic standards, forget about what the actual protocol we're speaking is. You're right. For RESTful APIs, the protocol we are speaking is HTTP. And we'll talk about why in a second. But regardless, both of these guys are standards, so that when I talk to one of these standards, I will talk to it the same way as I will talk to another third-party API that's following that same standard. We can say that has a benefit, right? You know, if there's a whole bunch of different third-party applications, especially as the internet becomes a bigger and bigger thing. I don't know if it can get bigger now, right? It's just big. It's superfluous at this point. So the idea is there's lots and lots and lots of service and data providers out there that we might want to talk to. And it would be kind of ideal not to have to reinvent the wheel every single time we want to talk to a different one, right? I might ask different questions using the same standard, right? Maybe he's Google Maps, right? And I'm asking for turn-by-turn directions of something. That might be a certain request where, you know, maybe you are like a cloud calculator or something like that. And I'm asking you to do some, you know, derivative or, you know, something, some calculus thing or something like that. You know, so what you're providing might be different, but the mechanism, where's Galib? The lights.
No, it's not. It's fine.
Yeah, we've messed with it. Now you're turning it off.
No, I just
All right, so we can say that in general, moving towards standards is a good thing. So what did we do before that? Before we had a standard, what do we have to do? Well, what's your perception? If there wasn't standards for us to all follow, what did we probably have to do? Yeah, we had to create a custom interface, right? If I wanted to talk to your company services, I had to write, you know, you would kind of make your own little proprietary, you know, mechanism for talking to your application. I would have to then, you know, follow that proprietary mechanism, and that's how I would talk to your services. But if I wanted to talk to his services, I'd have to follow a different proprietary mechanism. So before we had these standards, we needed to create proprietary interfaces for each API we wanted to talk to. Something along those lines. And we can say that, yes, that's possible, but much, much, much more time consuming. It would be better if we had, let's say by today's standards, a single standard by which all modern APIs, or a very, 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 very high percentage of modern APIs follow, so that no matter what API we're talking to, we talk to it in the same way. Okay, kind of like I walk into a classroom and I have 20 students in the classroom, they all speak English, so I'm going to default to the English protocol, and I can ask one of them a question, and maybe he knows certain things that somebody else doesn't know, and I can ask another student a question, and maybe she knows some other information, but I'm communicating with them in this using the same protocol. Make sense? We're using the same standard. All right. So where does REST APIs fall in? So you mentioned that RESTful APIs follow this HTTP protocol. All right. And I think we already had a slide for that, right? Yeah. So we said that, oh, this HTTP protocol has these 4 functions: get, post, put, and delete associated with them. So why did we move towards, let's see, what was the homework right here? So you mentioned we used to have this thing called SOAP, which was a standard-ish. So why do you think that we left that? Because if we just generically talk about this, isn't it fair to say that, well, having a standard way of communicating with an API is definitely better than a proprietary way of talking to an API? So with that in mind, once we had a standard, why change?
The way RESTful works, representation, and the way it works, and because it's dependent on HTTP.
Okay, so what's your perception of what was wrong with SOAP?
With SOAP?
Yeah.
From my experience, I only knew that SOAP used strictly XML.
Okay, we're going to be talking about that. XML is the mechanism by which we send data. Nothing says that a RESTful API can't also use XML. It's unrelated to the fact that it's SOAP, or we're going to talk about that today. That's the means by which we package up data to send it. All right, so neither of those guys dictate the way you package data.
So yeah, no, I thought the SOAP was strict with XML, and RESTful provides more flexible options.
Okay, so what was wrong with SOAP? We might say that SOAP had several, let's call it nuanced implementations. So there wasn't like a single standard, right? You know, there was a couple, I don't even know how many, but there were several different little derivations on the SOAP approach to stuff, where you couldn't necessarily rely on sitting down and you know, talking to, if the two of you both had SOAP APIs, there wasn't a guarantee that I could use the same code on my side to talk to both of yours. Might get us close, but it wasn't the perfect solution for it. All right, so if we say it wasn't the perfect solution, well, we had some options, right? We can either try to make a standard, move towards a standard, and that's sometimes difficult because, right, as the internet got bigger and bigger and bigger, moving towards a standard becomes a harder problem to solve. I mean, we've seen this more recently with when we had Flash-based websites, right? So you had Flash-based websites, and I'm going to create a slide for this. What was Flash? What is Flash? Okay, so it's made by Adobe. So Adobe companies called it animation-based programming infrastructure that allowed dynamic content on HTML-based websites, because HTML in and of itself is not a programming language. We want to have dynamic content on a website, well, our mechanism for doing that is either through JavaScript, which I think we talked about last time. I think we have a chart or something like that, a picture. Oh, we didn't actually finish putting in the JavaScript. That's fine. We're getting there. But you know, we enhance our websites by giving dynamic content to them through JavaScript or for instance, Flash. And Flash allowed us to have kind of a graphical user interface to stuff. Typically, it was used for animation-y, gamey type stuff, but it didn't have to be. You certainly could have created, you know, user forms or, you know, other applications. Sure. So what was wrong with Flash? Okay. So first of all, we don't have Flash now, right? It sort of exists, but generally speaking, it's not being supported anymore. There isn't updates. It's been supplanted. It's been replaced with HTML5. All right, but so we might say that you mentioned one of the problems with Flash is not open source. Is open source necessarily a good thing?
No, but it also means like the browser doesn't make it supporting that. You have to install the plugin.
Okay, yeah, so, but even with that in mind, I mean, just because it wasn't open source doesn't mean that your browser could not have come with it pre-installed.
Well, true, but you see that the mobile phone, usually their browser doesn't have that plugin on the mobile phone, right?
Okay.
Doesn't have the plugin.
Right, so we're going down a reasonable path now. So it was common for web browsers, whether it's on desktop or mobile, to not come with Flash pre-installed. But that was a choice as opposed to them not being able to. They certainly could have packaged Adobe products with the web browser. In fact, you know, that would have been Adobe's preference, I would assume. But instead, you went to a website and it says, this website requires Adobe Flash, click here to install it, yada, yada, yada. Now, you mentioned that at the very least, mobile browsers didn't have Flash installed in them. Why not?
Because it costs a lot of resource on mobile devices.
Yep. So, and not just mobile devices. So the example I used to use when Flash was more popular is if you have a laptop, it's supposed to get 5-6 hours of battery life, let's say, and you go to a website that had Flash on it, just let that website run, your battery will last for like 30 minutes. It'll just burn right through your battery, right through your battery, because Flash is just a resource hog. Flash was never built for mobile devices. As mobile got more and more popular, this became a less usable technology. On top of that, Flash on mobile devices never looked very good. So it wasn't even functional, is the punchline. So I don't want to go too far down the path of the whole mobile device thing. I was in a different class that we talked about that. But generally speaking, Flash had its day in the sun, right? And then the things that we were accomplishing with Flash were fine for desktop, but because so many people were digesting websites through mobile, Flash became a non-usable tool. All right. So one thing, so I'm not sure we can say that a problem with Flash is that it was not open source. If we're going to go that direction, maybe we could say something along the lines of that not being open source, we didn't have an army of developers maybe trying to optimize it for better battery life, things like that. So there was for iOS, there was a browser that supported Flash. And what it would do is it would offload it would send the request someplace else, render the Flash someplace else, and stream it back to so it was actually delivered Flash to you as if it was like a video stream.
Really slow.
Yeah, it didn't work well, but it was a thing. So that we were trying to find workarounds, but it was certainly a problematic type thing. So I don't know if it's fair to say that a problem with Flash was it's not open source, but it's certainly a fact. Flash was not open source. It was a resource hog. Very poor battery life on mobile. All right.
And it has a different kind of things like different programming infrastructure is actually using different language, different APIs.
Okay. Yeah. So you had to learn kind of the Flash scripting language in order to write stuff in Flash. Not the end of the world, but maybe didn't follow a known standard, except for the fact that for a long time, Flash was the only kid in town, right? If you wanted to have, well, that's actually maybe not true. There was a competitor with Flash that wasn't heavily used, but Java through a technology called applets was a legitimate competitor with Flash, even though it wasn't maybe quite as commonly used. What replaced Flash? We said HTML5, but one of the things that where I was segueing here with this is how do we move? If we just bounce back a slide, we were talking about that SOAP solved the problem for a while, and it solved the problem pretty well. But we decided we need something better because as we have more and more web applications or software applications requiring data or services from third-party things, it's becoming a bigger and bigger problem that we have these multiple SOAP standards floating around. And then on top of that, it wasn't necessarily that great of an implementation for some of the standards, so it would break. It just wasn't that great. So people might have said, well, we can start trying to fix SOAP, trying to create a single standard. How difficult is that? As the internet becomes this huge place and we have, a zillion different companies all wanting to start offering their data through different things, isn't it hard to get them to all agree on a specific standard? Especially if we're introducing something new. So if we start off by saying, well, SOAP's not the answer. Maybe we'll just be stupid and say, well, SOAP 2.0 is we brought all of the individual weird little twists and turns on SOAP. We brought them together to one central thing. And now everybody moves to SOAP 2.0 made by company XYZ, then all the world's problems are solved, right? But then who says that SOAP 2.0 actually doesn't have its own problems and that kind of stuff? So the idea was, and to finish this analogy over here, how did HTML5, so we're going to say replaced by HTML5. How did HTML5 finally replace Flash? What was the catalyst for this? How did it finally occur? Because HTML5 was out for a long time before Flash was finally effectively forced to close its doors. Not that Adobe's not still a company, but before that was no longer really an option. For a long time, places still had Flash on websites and were still making new development using Flash. HTML5 was not necessarily the cool kid. Not enough people were using it, where a lot of people were using Flash. So what was the thing that finally flipped the switch? Yeah, Apple. What did he do? What did Steve Jobs do? Do you know? Yeah, only HTML5, and it was really related to the iPad. When the iPad came out, the iPad technically would have had the horsepower to drive Flash-based websites, and Apple said, no, our devices, iOS, does not support Flash. Never did, never will. It supports HTML5. So if you want your application, your website, whatever, to function on iPad, on iPhone, it better use HTML5. Now, if that was Bob's computer company, would that plan have worked? No,
Probably not.
but it was Apple. Big enough company, big fish in a big pond, right? Okay, so Apple was able to make, so there's little nuanced things like that, whether we love Apple, hate Apple, whatever, you're indifferent. I don't know if we have that many people who are just indifferent about Apple. It's typically a polarizing company, right? But the idea, although the funny thing is out of the three of us in here, we're all on Macs.
Yeah.
Hey, but look, I got Linux on here, I got Windows on here, because at least I'm covering my bases. But in any case, you know, it took a big fish like that to take a stance in order to make a change. All right. Well, if we look at this through the lens of APIs, and we're saying that SOAP-based APIs are a problem, what was the catalyst to move us away from that? We're actually looking at a little bit different angle on this. The question is, we can say, well, we need a better standard. That's clear, right? The second you had enough companies saying, we want to connect to this guy's API and this guy's API and all the things like this, and they started saying, you know what, this is kind of a little bit difficult because we have to talk about like which of the 3 SOAP standards does this guy use, so we can make sure we're talking to them a different way. It wasn't the end of the world, but it was still inconvenient. You know, it's not like we had a different proprietary solution for every different place, but we kind of had 2 or 3 different solutions that we had to kind of strategically use. So as developers, we might have said, you know what, it'd be nice if there was a standard. All right, and we see this in real life all the time when you know, buy like a piece of furniture or a new piece of equipment or something that you have to assemble. And a lot of times, what do? They have like the proprietary screws that don't have the right, you know, you have to go and get some kind of special screwdriver tip in order to even, you know, use the screws, and you try to hack it, right? And end up stripping the screw. So we sometimes try to make things work. All right, but proprietary in general, we would say is not a convenient solution to things. Places that make things proprietary tend to do so to protect, to add a layer of protection to their intellectual property or something like that. All right, so these companies that had already established APIs in place that were following SOAP or whatever, these guys were not necessarily they didn't have a real strong reason to change their standard, right? Why should they put more development hours into fixing something that's not broken? You know, if we'll just pretend like we're using Google Maps for an example. So Google Maps, if you want to have turn-by-turn instructions, no problem. We implemented it using SOAP, you know, whatever, you know, SOAP standard 2. And you want Google Maps stuff, you speak to us as SOAP standard 2. It's not our job to fix our things so that you can more conveniently talk to us. You know, you want our data, you adhere to our standard, you know, whatever it is. So maybe if there was a big enough fish back then, we could have gotten one of the SOAP standards to kind of coalesce into this is the de facto standard. And if there's 1 or 2 big companies that are all serving their data using the same common standard, maybe that one would have become the winner. All right, we can go back to the early days of the internet. So we talked about HTML is not a programming language. So HTML is effectively our interface builder for websites. How do we add dynamic content to websites? Well, more modernly, we talked about Flash. All right, what came before Flash? And some of it's still around today, but what technologies came before Flash? Well, JavaScript is one of them, right? Anything else? Was there a competitor for JavaScript? So think about your web browser.
The Microsoft thing was called
Well, you're thinking ASP. Yeah, that's the
not ASP. Is Microsoft has its own like like a page update thing.
okay. Yeah, it was available day one, and he's right. It was made by Microsoft. It was available day one of the internet. It had the word script in it. VB script. This is Visual Basic Script. So in the early days of the internet, and for all I know, actually browsers today might still support it. Nobody writes it, but they might be backwards compatible with it. I would assume they probably removed it at some point just to remove some bloat. But your web browser would allow dynamic like form processing type stuff using both JavaScript as well as VB script. Well, JavaScript won that war, right? You can say, well, there was a time period there where Microsoft kind of ended up becoming the demonized company, right? Everybody hated them, so we're not going to use their stuff, even though we're forced to use their operating system if we want anything to work. But anytime we can kind of, kick Microsoft in the shins, we're going to. In any case, JavaScript kind of won out there. Both of these were dynamic programming languages that allowed our website to kind of come to life. All of these guys are client-side technologies. That is, they ran inside of the web browser, as opposed to server-side technologies. We're going to be making a distinction between these. All right, so these were all client-side technologies to add dynamic stuff to our front end, to the web page that we were viewing on our computer. You've put in a username and password and hit submit. You could have some JavaScript run and make sure that you filled in the password, for example, before it tried to send a username and nothing over the internet to a server that's just going to reject it because you didn't put a password in. So you can offload some of the work that you were going to put on that server, wasting its time. You can put that into the browser on just that person's computer and say, look, we're going to double check to make sure you're giving us at least a fighting chance in order to process your login here. So that's areas where JavaScript kind of came in for that kind of language. So HTML finally replaced Flash, going back here, when Apple said they won't support Flash for iOS, iPhone, and iPad. Big fish, big successful products. If a lot of people are using their products and you want your website to look good on their devices, you switch. That's what you do. You switch. All right. So this was really something that Apple drove. All right. Fair enough. So back to this guy then. So we could have had, if we had a company like Apple or something like that, driving some standard for API, which actually back then, I'm trying to think, Apple did have a technology, but Apple then was not Apple today. They didn't have the clout that they have today. Microsoft would have had the clout back then, but they didn't have their own. They were too busy buying up companies or probably acquiring technology and then getting sued and settling outside of court, which isn't necessarily meant to demonize Microsoft. I think most big companies, it's more convenient for them to do that. They can sit there and negotiate with you for 6 months to buy something from you, or they can just take it and then you sue them and they give you $1 million and you go away. Efficient, everybody's happy, whatever, problem solved. All right. So how did REST solve the standardization problem? What is REST based on? You said it's based on HTTP, right? Okay, what is HTTP? Very, very, very old protocol that had been around since the beginning of the internet, that was already tried and proven, i.e., already standardized, but only used for communication between web browsers and web servers. Or very, very highly likely that was the primary use for it. Not a lot of people were looking at something so old, so under the radar, things like that, and saying, hey, what else could we use this for? HTTP, used for a web browser, talk to the web server. You ask for a web page, you make a GET request, it responds with your web page. You know, you want to give it some data, you make a POST request, send it some data. It processes that data, however it's doing that on the back end. In the early days, it was using, you know, like a thing called CGI, Common Gateway Interface, and maybe with a C program behind the scenes. And then we went to Perl programs, whatever, but you could have dynamic stuff over on the server side. But right now we're talking more on the front end. But in any case, so since we needed a standard anyway, and there were inconsistencies with the SOAP standards, HTTP was deemed to be a solution. Why HTTP? Why did they pick that as opposed to some other protocol that had been around for a while? Why did they use HTTP rather than, I don't know, UDP or TCP/IP or Gopher, the Gopher protocol, which was like Google before there was Google? Why did they pick HTTP? What was the catalyst for this?
Maybe just because HTTP, as you mentioned, is consistent anywhere over the internet, with all supporting that, as long as you have the internet and you use the browser. And also probably because since it's not really owned by any company, so that is actually have more capability to matching the people's idea of internet.
Okay. So if I'm trying to give a different analogy, like for something at home.
Actually, if you look back at the rest of or rest what the requirements of the REST, I think it's actually designed on the HTTP. There was just
okay, so I like the way you're going with that. So you're saying REST is kind of designed on HTTP.
Yeah.
I think that's right, but for the wrong reason. So let me ask a question to see if we can get us down that path. What does an API, let's just call it, provide? We've already generically said it provides data and services, right? But if we had to kind of list the abilities that an API has, it allows us to request some data or service, right? It allows us to send some data or service. Well, let's see, send some data to add to the third-party database. It allows us to send some data to modify the third-party database. It allows us to send a request to get rid of something in the third-party database. Anything else you could generically come up with that APIs provide? Don't think about it in terms of HTTP or anything else. We just want to think about what's the use of an API. You're a software company that has some data or services that you want to provide to others. What's the list of things that they might ask of you? They might say, hey, give me some data or provide some service. They might say, hey, I have some data. Go ahead and add this to your collection of data. This might be handy. Hey, I have some data. It's data that you already have, but maybe yours is out of date. I've updated my pricing or something like that. So go ahead and fix your data with this. Or you know what, I no longer sell that product. And I was the only one selling it, so you could probably remove this from your data. Anything else an API needs to be able to do?
Well, the first thing keeping in my mind is definitely sort of credentials, like checking the security.
Okay, it's kind of like, am I allowed to do this? But isn't that also a request?
It could be.
Here's some data.
It could be in fact.
Yeah, so here's some data that I want you to do something with. I'm requesting to access your data. So you have a request. And as long as you provided the right magical key or whatever, you know, they'll let you access their data. All right, so generally speaking, do these four statements kind of cover the things that an API might provide? It does. With four things, four general ideas, we capture those things. And it just so happens that HTTP has functions for four things. Could we have picked some other protocol that had 7 different functions and only chose to use 4 of them? Yeah, certainly. We certainly could have done that. But maybe those 7 functions would have been less convenient of fits, right? Maybe it would have been, you know, we'll just come up with just generically bad names. Just maybe instead of being called, you know, get, put, post, delete, it was function 1 and function, you know, so maybe function 1 was make phone call or something like that, you know, something that's not necessarily related to the generic kinds of requests that we make of an API. So we looked at what is the problem we're solving. Whenever we need to come up with a solution to a problem, we always say, what problem are we solving? We always first ask, what problem are we trying to solve, and what is the high level solution to that problem? Once we have the answer to that, we can look for existing solutions, well, let's say existing products that fit our problem/solution, or we can invent something new. Well, we saw that inventing something new through like soap didn't necessarily work out great because we had too many companies all trying to invent something new. But with HTTP, we already had something that was invented. It had been tested for years and years and years and years. It happened to have exactly 4 functions. And it happened to be that those functions really were kind of made for these 4 things. I want to get some data. I want to post some new data. I want to actually post would be post would be posting new data. Delete would be getting rid of existing data. Put will be updating existing data. Okay, it was built for it. It was like a chicken and the egg type problem, right? You know, did HTTP exist because we need it for APIs, or you know, whatever it is. So HTTP was just the perfect solution. Do we envision moving away from this at this point? I mean, this is what I've always found fascinating about RESTful APIs is, and this is really about technology in general. And we see this with web every 5 minutes. So anytime you have loosely typed languages, scripting languages, you know, every 5 minutes there's some new language that came out that's supposed to solve all the world's problems. And really what it's doing is the same thing as the other 40 languages that are right next to it are already doing. But, you know, it's got some little feature that's going to make you jump ship because everybody else is already writing crap in PHP or whatever. They just think that switching to that Dart programming language is going to be something amazing. And maybe that is better. Maybe the language has some interesting things. But just because it's interesting doesn't mean that you're going to supplant 4 zillion websites that are already being that have already been written and are being managed in PHP. It's a tough thing to change, right? So in any case, unless we change our definition of the kind of data, the kinds of things an API should do, or we have a kind of a new concept, the next level of the cloud services, something like that, where we're no longer doing something for digestion or through a web page or something, but we're, you know, now maybe solving something we haven't even considered yet, right? So, you know, back in the 600s, we weren't really thinking about combustion engines and stuff like that. So it was off our radar, right? We're combustion engines, that's old news. We're looking at it, you know, newfangled stuff now. And, you know, back in the early days of flight, we had propellers and stuff. Now, new plane comes out, it doesn't have a propeller unless you're trying to save money. It's got a jet engine, right? And there's going to be something after jet engines, probably something with magnets and hovering and stuff like that. Who knows, right? You know, but we fast forward 50 years, we're probably going to look, it's like, man, can you even believe how dangerous it was when we were, you know, igniting jet fuel, creating explosions while we were 35,000 feet in the air? That just didn't, I mean, we did it every single day. That just doesn't sound safe. It's going to be hilarious when you go back. There was I've referenced it in some of my other classes. I don't remember if I've referenced it in here yet, but one of my favorite movies is a movie called Demolition Man. And they actually make this reference to combustion engines and like, you drove one of those cars that could possibly blow up at any moment, you know, that kind of thing. All right. So HTTP really solves the problem for us that we need to have solved. And then we don't have to reinvent the wheel because it was already out there. So now we can lay our APIs on top of an already standard protocol that we don't have to worry about there being different standards and do everything through there. And that's effectively what a RESTful API is. All right. So I've always found it fascinating with RESTful APIs that the newfangled, most modern way of handling APIs is actually based on one of the oldest protocols that exists on the internet, HTTP. So it doesn't, we don't always need new things to solve modern problems.
SOAP is older than HTTP.
Well, SOAP isn't even a real protocol.
It is a protocol.
Well, I mean, SOAP in and of itself isn't a real protocol. It was somebody's decision saying, hey, I want to create a way to talk between two things.
Yeah.
So, I mean, the early days of that thing wasn't necessarily meant for web communication.
Yeah, it wasn't
They just
I'm
used it.
saying is the internet coming after people
Right.
already using SOAP for some years.
Yeah, so SOAP was used to solve a different problem.
Yeah.
And then they said, oh, well, we're going to apply that to this problem. All right. So going back to this picture right here, when, so I just want to put us back into what we're trying to do here. So under normal circumstances, our web client is digesting HTML. So it's speaking HTTP across the internet here, right? Okay, and it's making requests. So this is our web client, but we can now also, in fact, I'm going to just copy this slide and we're going to put it after this guy. And we're going to call this guy Internet API ecosystem. Actually, what I'm going to do is I'm going to do it like this. We still have a client server model like this, but the nature of our clients has now changed. So we can have a web browser. We could have a mobile app. We could have a desktop app. And I'm just going to we could have a smart fridge. Yada, yada, yada. Which effectively, this is really saying this is probably a mobile application, well, some kind of application running on this smart fridge that is talking to this. Here, we'll add one more thing. We'll add a smart toaster to this, right? Punchline of what we're looking at here is we have various products, various types of clients that want to leverage HTTP for getting data. All right. For our world here, we're going to throw one additional guy here. We could be talking to Apache IIS. For us in here, I'm going to add one additional thing here called Express. All right. All of these guys are effectively HTTP servers. These are pieces of software that understand the HTTP protocol. I'm only putting Express on here because we're going to be using something called the mean stack. We talked last time about the various stacks that we can have, and the mean stack is uses MongoDB. It uses Express as our web server. It uses Angular as our front end dynamic-y thing, and then it uses Node.js as our back end server. All right, so really it's Node.js and Express kind of working together to provide an HTTP wrapper around logic. Okay, so we're going to create endpoints. We're going to say, hey, I want turn-by-turn directions for this address, right? And the Node.js server is going to receive that HTTP request through Express. And then it's going to say, what request did you make? It's going to give you an address in some format. We'll talk about JSON versus XML. Some address in some format. It's going to then have the code where, okay, I'm going to go and do my magic, right? Because I'm, Google Maps, and that's presumably a complex application that was, written by Google. And then, really the magic behind Google Maps has very little to do with the front end software. The magic's their data, right? Their real-time data, the collection, all that stuff. And, now we have the street view and stuff where you've seen, I don't know if you've ever seen a little Google minivan driving around or something like that with cameras where, you can go anywhere in the world and look at the street view and, that kind of stuff. But we get the point, right? Google's secret sauce is their data. all around, right? They're a data company. And then they have a lot of customers. And then what are they doing? They're giving other people access to those customers. Customers search for data. They're saying, hey, you want to sell them a widget? And they search for that widget. We're going to let your thing show up first. We're going to charge you a bunch of money for it. Done. Business model, right? Huh? Yeah, they've done all right. Yeah, Google's, they'll probably be around for a bit. But it actually, even historically, you look at it, is kind of interesting. Google feels less cool today than they were, say, 15 years ago. Google was kind of like the hippie, changing the world type company 15 years ago. And it's not that Google isn't still doing things like that. Google's a very innovative company, but they no longer feel like the shiny quarter that just came off the mint. They're now an established company that's got their fingers in all sorts of different things. They're invested in, just like Microsoft. Yeah, you go back into the 90s, Microsoft was the cool kid, right? You go back into the 80s, IBM was the cool kid, right? IBM's still around. IBM's still a major, major, major company. Just we don't think of IBM as being cool. As they start getting into with Watson, I'm guessing you're going that direction with some of their machine learning stuff, IBM Watson. What do you think? Well, right, but then so they might get back on the radar. And who's their real competitor with quantum computing? Google, right? And you're going to have Amazon's probably got their toes in that pool and stuff like that. So the point is that that's not because they're cool. That's because they've built empires where they have the research R&D dollars in order to go down a path that sounds good on paper. We've been talking about quantum computing for years and years and years and years, and we can say that quantum computing sounds powerful, but are we going to find very practical uses for it? And the short answer is probably, but will we find practical uses early enough? The thing that kind of pops into my head related to that is for a long time, like when I talk about desktop processors, what's the first company that comes to mind? Desktop CPUs, Intel, all day long, right? Okay. Now, does Intel have any competitors? Yeah, they got one. Who's the competitor? Well, ARM is an architecture. AMD, yeah, AMD. So AMD is the company that competes with Intel, right? And if you were buying a top tier, actually, this is a little bit of a loaded question now because I think AMD is once again playing catch up. All right, but let's go back into what was it Pentium 3 days? Probably Pentium 3 days for Intel. AMD was becoming a pretty cool company, and AMD came out with a chip that was Intel had an experimental chip that was supposed to be released for like business applications. That was IA64. It was their Itanium processor, which is a 64-bit processor. But it was only for commercial, like enterprise type server stuff. And it never really became a thing. It became the foundation for their future processors, I'm assuming. But AMD came out with a processor that was the AMD 64. It was right around the time of their, they had a processor called the Athlon processor. And so they came out with these chips, the AMD 64 chips. These were native 64-bit processors that could also operate in 32-bit mode because there was a transition period there, right? Okay, so for a while, this was the cool kid. It sounded great on paper, but what was the problem?
Not only the OS, but also the application cannot really run on the 64.
Yeah, none of your software supported 64 bits, including the operating systems. The only way you could truly take advantage of your AMD 64 processor was how? No, what you would have had to use Linux.
Okay.
Linux had a compiled 64-bit kernel,
Got it.
and they had because a lot of the software on Linux is open source. They were able, you had a community that, had some interest in recompiling their stuff for 64-bit, so it would work, and and you gain that 0.2% of the speed or something like that. That wasn't a game changer yet. So we can look at AMD and say, you know what? They really came out with something pretty cool first, but they came out with something pretty cool too soon. We didn't have practical uses for it yet. And even, and really for a long time after that, many, many years, 7, 8 years. I mean, we're not talking about like 2 years later, before 64-bit processors and the software that would run on 64-bit processors were really even in negotiations, right? When you had Windows Vista came out, the default version of Windows Vista was a 32-bit version, but they also had a 64-bit version of Windows Vista. Then when you went and ran the software, you had half your applications. Well, really, you probably had 85 or 90% of your applications that were still 32-bit. And then you were able to take advantage of a couple of 64-bit applications. And when you went into your C drive, you would see that you would have a program files folder for 32 and 64-bit. In fact, you probably still have that today in Windows. I bet you they maybe have both of those just for backwards compatibility with old 32-bit software that you need to run in compatibility mode or something like that. But in any case, sometimes we have really, really, really cool hardware, really cool ideas that just come out too soon. The world wasn't ready for them, right? Something like that. And then, the early adopter gets passed up and somebody later on does it at the right time. Something along those lines. It just kind of becomes I think an interesting thing. What was the statement I made before that got me off on that? I mean, interesting tangent, but not where I was going. Oh, right. Yeah. So these are no longer the cool kids, right? But they're the ones with deep enough pockets to innovate. And there's going to be some, I'm sure right now, there's some company that's in existence right now that we haven't heard of or we've barely heard of that is the next cool kid. Right now, if we had to point to a cool kid that's really almost back in, to the same level as Apple and Google, maybe they really are, is Amazon, right? Amazon started off as a bookstore, then it became a shop for anything thing, and now they're a grocery store. You can get stuff the same day. They're making drones. They're involved in space. Amazon's not the old. They're the infrastructure. They're probably the strongest infrastructure for cloud computing. They're all over the place.
And Amazon actually that's a little later than Google, right? They were founded in 1990.
Yeah. But when did they come into their own? I mean, Google was sexy much earlier than Amazon was. Yeah. Amazon was a bookstore. Jeff Bezos was, it was literally an online bookstore to like compete with like Barnes and Noble.
What I mean is, even though Amazon might be, this is fancy kids, but I would say people don't really think it's that fancy because it's already in our eyes for too long.
Yeah, now. Right. I get what you're saying. I get what you're saying. And I think a lot of us do also demonize Amazon because how much money they have.
I would say things like I would really refer to companies like Tesla would appear more like
Tesla feels like the cool kid right now. I think that's a good example.
I just say Amazon yes, they have a cool thing, but it's already like
Google. Yeah, Elon Musk with Tesla. We got rockets that are landing themselves. We got self-driving cars. We got all sorts of crazy stuff, and then Tesla does other, well, it's not through Tesla. Elon Musk has a company called the Boring Company, and the Boring Company a couple of years ago, they sold flamethrowers. Just cause. Like, you know what? We need to have a flamethrower. Of course you do. And you know what? They sold out in like 10 seconds. People bought those flamethrowers.
I do remember. If a dealer is showing that actually anything sells pretty quick.
Yeah, everything they do, you know, and even look at the innovation that comes out of Tesla. In fact, an interesting thing, this is a much more recent comment that Elon Musk just made, which I found very interesting. So the Tesla cars have been out for a while now, right? I don't know how many years, 6, 7, 8 years. I mean,
Yeah.
not just yesterday.
7 years. I think.
Yeah. But even in the earliest days, you know, you would pay a premium if you wanted to get the full self-driving ability. Your car didn't come with it, a compatibility. It was compatible with full self-driving. So let's say you bought a Tesla 7 years ago. Now, there are people who keep cars for 7 years, but I might say that the people who buy Teslas maybe are not the type of people that keep cars forever. You know, maybe they flip them. Like, I mean, I keep a car for 2.5 years, and then my cars are like my cell phones. And it's because I like technology. So these are just decisions we all make, right? Some people, I'm not a car guy, but I'm a tech guy. You know, where some people, they, you know, yeah, I have some students, and I always found it funny, like computer science students, like, well, shouldn't you always have the latest, greatest cell phone? You know, the smartphone, because you want to have all the latest technology. Well, I mean, if money grew on trees, maybe, right? You know, but I mean, I'm sure every one of you would, you know, in the room and also online would like to have a new phone every 3 months. Whenever the new phone came out, just get rid of the old one, get a new one, move on with life. But that's just not practical for most people. I get a new phone every year. I'm on, you know, one of those yearly upgrade plans, but what does that come with? It comes with the assumption that I'm always going to have a phone payment. I could just buy the whole phone out, but it's just more practical. I pay my, whatever, 35, 40 bucks a month. I always have whatever the bleeding edge phone is. Next year, Samsung, if I stick with the Android ecosystem, comes out with their new bleeding edge phone. I turn this one in and I get the next one, and it's still $45 or $48 a month or $42 a month, whatever it is. I always have that monthly payment. Same thing with my car. You know, you're always going to have a payment for a car, and sometimes you swap the car for a new car. Still got a payment. You still got that payment, but you always have relatively recent technology. But something I found, so for like 7 years, when you bought a Tesla, you were buying it with the, you know, most people, I would think. I mean, I think you do have a percentage of people who go to Tesla for the, you know, the electric aspect of it. That was not an interest of mine at all. Mine was the technology behind the self-driving stuff. But so for 7 years, people have been paying this premium. You know, it was $2,500 at first, I think, and then it was $4,000, then $5,000, but now it's $10,000, right? You buy a new Tesla today, you can immediately tack on 10 grand for a feature that does not exist. It almost exists, okay? But the thing is it's almost existed for years, right? By the end of the year, you'll have self-driving. By the end of this year, you'll have self-driving. By the end of this year, you'll have self-driving. They keep telling you that, and it keeps getting the can kicked down the road. Now it feels a little bit more real because now it's in like a mature beta. So you see like, you know, you see YouTube videos. They're showing people, you know, using it in their car acting weird through intersections and stuff like that, which just seems exciting. But, you know, whatever it is. But you have this guy in the center, and Elon Musk said something very interesting the other day, and I see the truth in it just from my own experimentation with my Tesla. And he said he doesn't think that we'll ever have fully autonomous vehicles. And that's a different statement than he's made in the past, because he has this idea that your car, you know, will, you know, he wants to create like a competitor for like Uber, where your car dumps you off at work, you go in for the day, your car goes off driving people around, making you money while you're at work. And maybe this isn't exactly what he was saying, or maybe it's we're waiting for that next step, but or maybe that gap closes with machine learning and AI. But right now, the car, I would say, with the things I've seen with the self-driving and the things I've seen like with the interstate driving and stuff, I would say the car drives itself on the interstate. I think it's strong. That's the thing it's been doing for the longest, is interstate autopilot and that kind of stuff. But when I watched some of these videos for the full self-driving, and I should have it, I expected to have it last week. Maybe I'll have it this week. Who knows? Maybe the beta will come out next week. But soon. I should have it soon. I expect there to be a lot of strange behaviors, right? Where probably 95% of the time it does well, but then it does something weird. It waits too long. It needs to make a right-hand turn, but instead of turning when it's clear, it waits for the green light. Well, we can say, well, technically it's following the law, but you're also ticking people off behind you. It's not behaving like a human would behave. Certainly, we'd rather it do that than run over people, right? So we'd rather be safe than sorry. But we do need to ask ourselves, and this was something that was interesting that Elon Musk said, whether or not human beings, and I feel like when I heard his statement, this is kind of how I interpreted it, whether human beings themselves would ever be able to program a car to be fully autonomous. My feeling is if you're going to close that gap, it's going to be done through machine learning. It's going to need human beings overriding the full self-driving system for long enough where a person comes up to that red light, they want to make a right-hand turn, it's clear, a person would make a right-hand turn then if it's legal to do it. Right now, the car is waiting at the red light till it turns green. The human takes over enough times, that then gets integrated into the global knowledge, Skynet, if you will, if you ever followed the Terminator movies, where all of a sudden you can have these things that are behaving more and more and more like human beings with the reflexes of robots. And I was telling Blade the other day, I was coming home from Mequon, and it was dark out. I was on Port Washington, and there was a whole bunch of deer that ran across the road. Now, I would have seen them. It wasn't like a major accident issue. But there was a lot, like 5, 6 deer, something like that. And my car started slowing down, and I didn't know why. It saw the deer way before I did. Way before I saw them. 4 or 5 seconds before I saw the deer. So things like that, and there's a video on YouTube that I've seen that's very interesting. This is from a while ago with autopilot on the interstate, where a car was going along. I don't remember what town it was in, but it slowed way down. And so the driver of the Tesla is thinking something's wrong. And then there was like a 5-car pileup, like, 400 yards in front of them. This car noticed things that were happening that a human being just can't notice. But an innovation company like Tesla, I think to Blade's point, I think is our current cool kid. What are they going to do next? And he's got his fingers and all, he wants to send people to Mars. He's got rockets that are, going up and coming back down and landing, cars that are driving themselves, flamethrowers, just cause we have to have flamethrowers. It's a very interesting innovation world that we're in. But sometimes, and we see it in technology in our world, in computer science all the time, where sometimes technologies come out and they're a little bit ahead of themselves, right? They're ahead of themselves. So there might be some things that we talk about in here that feel like they're based on old stuff, and we keep just kind of shining it up, maybe putting some pretty wrapping paper on it, but it's the same technology as we were using 4 years ago with a sexy name or something like that. All right. So let me just kind of finish up this slide, and that'll give us a stopping point for next class. No homework for next class, but we probably won't have anything over Easter, but that's fine. We need to get into our starting point for Node.js and stuff anyways. So we'll do that on Wednesday. But in any case, we are going to be using a web server called Express. which is a product, a module that runs inside of something called Node.js, which we'll be talking about next time. All right, so this is going to be our HTTP server. This guy will speak HTTP. He will hand off requests to your Node.js program, and your Node.js program will create endpoints. For instance, give me turn-by-turn instructions to this address, or tell me the current stock price for Apple, or, you know, what's the weather today in Grafton, you know, that kind of stuff. So we'll have different ways of asking for data, different ways of posting data, different ways of, so asking for data will be through a GET. We'll have GET requests coming into the Express server. We'll have POST requests coming into the Express server. We'll have PUT requests. We'll have DELETE requests. So the type of request that comes in allows us to kind of filter it into the right bucket of, this is where I deal with deletes, this is where I deal with posts, this is where I deal with puts, this is where I deal with gets. And then within each of those within each of those function calls, we can then have different endpoints that some require input, some don't require input. So we can almost think of an endpoint as a remote function. And years ago, before we had APIs, Java had a technology that allowed you to do remote method invocation, RMI. So it was kind of a predecessor to, well, not really a predecessor. It was an implementation of an API approach that said, hey, you want to have a non-HTTP application running over here, even though it might have been implemented on top of HTTP, I'm not positive. But you want to have a non-HTTP based program running over here, and you have a Java program running over here, and you want this program to be able to call a thing that's running on a server over here, rather than establishing a connection this way and sending stuff over HTTP. Instead, you'll just invoke functions in this remote thing, and it'll handle that infrastructure, whatever was under the hood for you. All right. So the problem we're going to be solving in here is not a new problem, and there are multiple very similar solutions to this problem. We just happen to be choosing a certain stack that is modern, currently heavily used, not necessarily the most heavily used, it might be, but it's certainly in that conversation of the popular ones. All right, questions, comments, concerns, bribes? All right, I will see everybody on Thursday. Keep forgetting what day of the week it is.
Well, just because we have classes.
Right.
Wednesday, 2 weeks ago.
He's thinking about his diamond. Wow,